All right, so today we're going to talk about the standard normal distribution. So this is lesson 5.6, and we're going to talk about this curve, the normal curve. So you've already seen us talk about this a little bit with the z-score, right? So don't forget that that's your x value minus your mean divided by your standard deviation. That's how you find your z-score. Again, this is your z-score. Okay, that's how to calculate your z-score. We're going to look at the curve a lot today and really help explain it a little bit more. So what these percentages mean is between one standard deviation, between -1, +1 standard deviation away from the mean, 68% of the data is going to fall between that standard deviation. Between -2 and 2, 95% of the data is going to fall. And then between -3 and 3, 99.7. So that's an easy little group of numbers to remember. 68, 95, 99.7. Okay? So again, 68 is between -1 and 1, 95 is between -2 and 2, and 99.7 is between -3 and 3. And then you might be asking, well, that doesn't equal 100%, Mr. Elliott. Well, it's right. It doesn't. There's still 0.3% we have to work on, which that is in these little tails. And we'll talk about that. It's in the little tails way out here. It's a little bit of percentage way out there, okay? So let's go into looking at these. All right. On this setup, it says we have a recent intro stats quiz. It has scores that closely followed a normal distribution with a mean of 80 and a standard deviation of 10. So there was extra credit on this quiz, and you'll see why here. So to start out, we have our normal curve. Our mean was 80, and our standard deviation was 10. That is how you will always label these curves. You ever draw a normal curve, you'll label it by saying N for normal, and then you list your mean value and your standard deviation. And that explains how the curve will be laid out number-wise. On this setup, it said our mean was at 80. So our mean is 80. And then it says standard deviation is 10. So if I go up 1 standard deviation, so +1, I would get 90. If I go +2, so another 10 on top of that 90, I should get 100. And if I go up 3 standard deviations, so another 10 on top of that 100, I should come out to 110. And then if we're going to go down, if we're going to take away 1 standard deviation, that would take 80 minus 10 would give us 70. And we'd have 2 standard deviations below the mean would give us down to 60. And then we take another standard deviation away, go to -3 standard deviations away from the mean. That should take us 80 minus 30 would give us 50. So again, each standard deviation is in 10 intervals of 10. That's how we're looking at this. And with those percentages, what I was referring to is, it was saying between 1 standard deviation, so right here in the middle, 68% of the data. When we're looking at between 2 standard deviations, so from here to here, we're talking about 95%. And then if we were to look at -3 to +3, we should get 99.7%. So again, you're thinking, well, where's that other little 0.3%? Again, it's to be split up on the tails. So on the tails, we have those values right here on the tail. So past that -3 standard deviation, we have 0.15%. And on the upper tail, we have that 0.15%. So with that, That then would equal all 100% of your data under the normal curve. This is very important to take a grasp of and put to memory a little bit. Definitely working on future problems because this curve will come into play a lot. So understanding that between one standard deviation from the mean, 68% of the data, between two standard deviations from the mean is 95%, and between 3 is 99.7. It's definitely a good way to remember. So also with this, that extra credit, again, we saw as extra credit because, well, this extra credit is sitting right here. Because apparently they could get more than 100. So it looks like they get up to around 110 for the most part. So therefore, that's how we know there's extra credit on this. Otherwise, it probably would shift a little bit. Your third standard deviation probably sitting around maybe 100 possibly. But for right now, we'll say that's how it played out. Now, if we're to look at this, and let's say that we had a student score 60 on there. So what would be the z-score of 60? Well, of course, you can look here and you can see that 60 is sitting right there in -2 standard deviations, right? But don't forget, that may not always be given to you right off the bat. So for your z-score, again, that's your value minus your mean divided by your standard deviation. So for this problem that I just told you about, we would have our z-score would equal 60 minus 80 divided by 10. And that would simply give us -20 over 10, which gives us a z-score of -2. So again, 60, a grade of 60 is 2 standard deviations below the mean. Right? So a score of 60 was 2 standard deviations below the mean value of 80. All right. So if we were to do that, and we're wanting to say, what is the percent of students that scored lower than that 60, that person that scored a 60, we would want to, first off, let's shade the area under the curve to the left of that score of 60, that -2 standard deviations. So in other words, we want to know this area under here to determine what percentage of people scored less than a 60. Well, we know that from 2 standard deviations away from the mean, if we go from here to here, that's 95% of the data, right? So if we were to take 100, the area under the curve should be 100%. 100 minus 95%, that'll give us 5%, correct? However, this is just one tail. If you just subtract 95, that's also leaving this upper tail as well. So to do this, then you would need to take that 5 and divide it by 2 because we have 2 tails. So therefore, that would come out to be 2.5%. That is saying that the area under the curve less than the grade of a 60 is 2.5%. So 2.5% of the class scored less than a 60 on the exam or on the quiz. All right, so let's say somebody smart out there, I don't know, pick Marty. We'll just call a name out there and say Marty. Let's say they scored a 90 on the quiz. So let's calculate the standard deviation and interpret that a little bit. So if we're given the value of, let's say Marty scored a 90, and we want to know how many standard deviations away that is. So to do that, again, we do what we did a minute ago. We find our z-score, right? So our z-score, again, is your x value minus your mean over your standard deviation. Well, the mean standard deviation is given to us right over here. So we should simply just be able to say this equals 90 minus 80 divided by 10. And we should get 90 minus 80 is 10 over 10, which equals 1. So we should have a positive 1 standard deviation away. Well, right here, so we know this is 80, 90. So 1 standard deviation away. So we know right here is where Marty is at. So now let's see the percent of students that scored less than Marty. So with that, again, we're wanting to find the percent. So the area under this curve from 90 all the way to negative infinity, all right? So we're going to find that area right there. So to do that, we can do this kind of easily, right? So what's half of the curve? If I went from negative infinity to the mean right here at 80, that should be 50% of the data, right? So I know I'm going to have 50% of the data. And then I know we're going to add this last little bit here from the mean to positive 1 standard deviation. Well, what do we say the percentage was between negative 1 and 1? That was 68%, right? Well, could I just divide that by 2 and get this other area over here? So if I took 68 divided by 2, that should give me the area. So I should get 50 plus 34, which equals 84%. So what that's telling me is 84% of the students scored less than a 90 on the exam. So now that we've been working with some whole numbers here, let's look at something that's not really so easily given just by our graph. So in this one, let's think about if somebody got a score of 97.4. So let's say they got a score 97.4. So what is the z-score? That's what we need to find out. What is the z-score? So again, in order to find the z-score, it's going to equal your x value minus your mean over your standard deviation. So for this one, our z-score, we have 97.4 for our x value minus 80 for our mean divided by 10 for our standard deviation. So if we do this, that should give us what up top? It's going to give us 17.4, and we're going to have 10 on the bottom. So if we divide that by 10, we should get 1.74 for our z-score. 1.74 for our z-score. So again, with that, with the interpretation of that, we're 97.4, that is 1.74 standard deviations above the mean. That's meaning. So it's up here. So again, if we had 80 right there, let's put this in a different color here so it makes a little bit more sense, easier to read. Just use black on this one. So we got 80, and then so 1.74, so let's say somewhere like right in here. So 97.4. Okay, because if we're to look at this again, our z-score is 0, and we have 1, 2, so this is our 1.74. Those are basically the same number. In essence, it's talking about the same area under the curve. 97.4 is the actual score value, but the actual z-score for that is 1.74. So with this, what is, let's say, what is the area, or what is the percent of people that scored less than this score? So we would again be shading. So we're going to shade. If we wanted to find that, we're going to find this area, right? Well, since we have this decimal here, it's not as easy to calculate, right? We can't just add up our 68s and 95s and divide them by 2, whatever the case may be. What we need to do is actually use a program to figure this out. So we can easily do that. If you have a calculator, if you have a TI Inspire, you can simply go Menu, 652 for normal CDF. And with that, it's going to ask you initially your lower bound, which is in that case negative infinity. Your upper bound is going to be this value that we found for our z-score, the 1.74. So 1.74 is your upper bound. Your mean is 0, and your standard deviation is 1. And we put that in there, we should come out to get a 0.9 something. Let's figure it out. We'll figure out our calculator. Let me pull it out real quick. So if we did this, Menu 652 for normal CDF, again negative infinity, then we had 1.74. And all we knew is okay, because our mean is automatically 0, standard deviation is 1. All right, so it comes out to 0.9591, we'll say. So 0.9591. So that is 95.91% that test score, that quiz score, okay? So the area under the curve is 0.9591. All right, so if we need to figure this out and we don't have a TI Inspire, let's go ahead and use the Desmos Calculator. So the Desmos Calculator here, when you get here, you click on this little keypad over here. It opens this up. You want to go to Functions, and you want to do Normal Distribution. And you want to leave the normal distribution. Well, our mean is 0 in this case, and we have 1 for standard deviation. That's what it's calling for. And then to find out what the area under the curve is, what we're looking for, click this little box here that says Find Cumulative Probability. Our minimum in this case was negative infinity, so we went all the way to negative infinity. And the highest we went, our z-score, was 1.74. And as you can see, that gives exactly what we got on the TI Inspire, which is 0.9591. And it even shows us how it's shaded and everything else. We can even zoom in to see it a little bit better. You can see the shading of it right there in the Desmos Calculator as well. Pretty cool little feature. All right, so hopefully that helps explain things a little bit more. Again, we're dealing with understanding the z-score and how that plays out for normal distribution. So we're going to jump into this a lot more with future problems and lessons. So definitely grasp an understanding between 1 standard deviation, 68%, 95% is for 2 standard deviations, and 99.7 is 3 standard deviations. All right, guys, hope you learned a little bit of something, and I'll see you next time.